Alright, welcome to my desk, where today I will be showing you how to graph cosines. Now then, allow me to get comfortable, please, so that I may show you properly. Now then, today we will be working with the following problem. Where is it? There we go. For cosine of 2x plus pi minus 2. Now, in terms of the x-axis and how it works, pi is essentially 2, based, at least when graphing cosines on an x-axis, if you were to plug this into a calculator. So, in order to have most of the basic things so you can graph it yourself and not use a calculator, you're going to have to find the amplitude, the period, the vertical shift, and the phase shift. Finding the domain and range are fairly optional unless whatever you're working on requires it. The domain will almost always, unless you're told otherwise specifically for that problem, your domain will always be negative infinity, infinity with open parentheses. Alright, so first off, amplitude. Right, now in order to find any of these, really, you need to find what I like to call A, B, C, and D. And each of those correspond to one of the extra letters, extra values added to the parent function, which is this one, y is equal to cosine of x, which on the graph is the supposedly red line. See that? That's how it would look if the graph looked like mine. Well, at least to the scale I used. Anyway, back to this. So the amplitude, based off of this one, would be the 4. Now each of these correspond to one section of these. So A is the 4, the coefficient in front of this part, at least. Then you have B, which is the coefficient in front of x. Excuse me, my cough is terrible today. Then you have C, which is this external part right here. This thing that is nothing related to anything. And then you have this plus pi, or technically plus 2, which will create a phase shift. Now, for A, B, and C, you do just put these into their appropriate spots. So, amplitude is 4. Oh, correction. A, B, C, and this pi here, or 2, depending on how you're looking at it from the x-axis. D, so your D will be opposite the sign that is there. So let me just erase some of this right here. So as it's plus pi, as it's plus pi, you would think it would be, since it's opposite the sign, negative pi, alright? But this is actually incorrect. What it actually is the 0 to this factor here. So I'm going to assume you've done polynomials, or solving for polynomials, so you'll know that in order to find the 0 of the graph, I guess you could say, you put in 2x plus pi, and then you solve. So you'll end up with, hopefully, negative pi over 2. So that is your phase shift. Just realized I did not shift the paper to show you what I did. But here is the work. There's something in my throat. The vertical shift will be C. So, I'll explain what that does in a minute. And then your period is based off of the formula 2 pi, which is considered, I guess you could say, like a 1. It's basically the standard period for the parent function, as you can see. Over b. So in this case, 2. So it's 2 pi over 2. Yeah. So your period would end up being, just zoom out a little real quick. So your period will be pi. And I'll explain what all these things do in a minute. So first off, let's start with the vertical shift and phase shift. Now, as I said earlier, plus pi, or pi, I guess you could say, is at least when we're referring to the x units, it's essentially 2. So pi over 2 would be 1 unit. And with the negative, you have -1, becoming your new, so to speak, y-axis to work on. So then you have your vertical shift, which is -2. So that means that you start your entire chart on the y-axis of -2. So this becomes your new x-axis, so to speak. Now, for your period, you normally go with a little trick that my teacher taught me. H, M, L, M, H, which basically stands for high, middle, low, middle, high for graphing cosines. As you can see from the parent function graphed here, the red line, you start at the highest point possible, which is, in this case of the original, 1. Then you go to the middle, which is on the x-axis. Then to the lowest point, which should be, in this case, -1. Back to the axis, and then back to the maximum. So the same applies here, but because of the amplitude, you're not going from 1 to 0 to -1. You would go for, technically, if there were no vertical shift, you would instead start from 4, go to the middle, go down to 4, back to the middle, and then back up to 4. So technically, your wave would look like this. But because of the shifts as well as the change in period, it will look a lot different. So 1, so you start at your origin, move up 4 units. This is the start of your graph, going from the high, middle, low, middle, high. So because of the change in period, rather than being like the aforementioned V shape you would get around about here, you will instead have to compress this entire thing into half the space. Excuse me. So you'll instead go from this point to the middle halfway, back down to touch the axis, back up to a middle, and then back up to a high. Because this being 2 units, i.e. pi, because of what I explained earlier, pi being 2 and all, on the x-axis, this is how your graph would look continuously as per the fact that the domain is infinite, unless you're told otherwise by your teacher or instructor or whatever, or whoever is teaching you. Sorry, not whatever, I don't want to be mean. Pretty sure they're a very nice person, and if they aren't, well, you're probably going to be stuck with them for a while, so you might as well get used to it and get nice with them, but not too nice. Now, this is how you would graph. Now, there is one last thing we are missing, which is the range. Now, the range, for those of you who have never graphed, at least this way, or have had to find the range, it is basically the highest y point and the lowest y point. So in this case, 2 and negative 6, which when you write it down into the space, it would be lowest and then highest, which is negative 6. 2, and since both points are included, you would use brackets rather than parentheses. Had this been a point where 2 and negative 6 were not directly included but were very close to, you would use parentheses like in the domain. And that concludes graphing cosines. Thank you for joining me. And the whole thing was cricket. Okay. Cool. That's fine. That's fine. Oh, and the entire video is upside down. Yeah.